So here in this video we are going to solve one numerical on hydrostatic force on plane surface. So after seeing the theory of hydrostatic force on plane surface, which includes the formulas or definitions of total pressure and center of pressure, let us calculate it for the following given example. So here it is written that determine the total pressure on a circular plate of diameter 1.5 meter which is placed vertically in water in such a way that the center of the plate is 3 meter below the free surface of water. Find the position of center of pressure also. Okay, so what is given in the question? That a circular plate of diameter 1.5 meter is given which is placed vertically in water in such a way that its center is 3 meter below the free surface of water. So let us draw a circular plate which is 3 centimeter in diameter and it is placed in water in such a way that the center of the plate is 3 meter below the free surface of water. So suppose if this is the center of the plate, then and if this is the free surface of water, then it is placed at a distance of 3 meter and this meter is h bar, as we have discussed in our previous video. Okay, so here now we need to calculate two things, first of all total pressure and then center of pressure. So what will be the total pressure that will be exerted on this circular plate disc by the water when it is immersed in water? Okay, so let us write the formula. F is equals to rho g a h bar. Here rho is the density of fluid and as our fluid is water, density of water is 1000 kg per meter cube. G is gravitational acceleration which is 9.81. A is the area of the immersed surface. Here immersed surface is the circular plate. So the area of the circular plate will be pi by 4 d square. Diameter of the circular plate is 1.5 meter. So 1.5 whole square and h bar is 3 meter. Okay, so this is the total force that will be exerted on this circular plate and it is equals to 52,002.81 Newton. I have pre-calculated this value, so you can cross check it by calculating yourself. So 52,002.81 Newton will be the total force that will be exerted on this circular plate. So this is our first answer, that is total pressure. And as I have discussed in our previous lecture, that total pressure is actually force which is exerted by the fluid on the immersed surface when the fluid is at rest. Okay. Now coming to second question, that is center of pressure. So as this circular plate is placed vertically, we will use the equation h star is equals to Ig upon A h bar plus h bar. Now here the value of Ig for circular plate will be pi by 64 d raised to 4. So pi by 64 1.5 raised to 4 and it is equals to 0.2485 m raised to 4. Okay. Substituting this value of Ig over here, 0.2485 divided by area is pi by 4 into 1.5 whole square into 3 plus 3. So the value of h star will be 3.0468 meter. So this total pressure will act at a distance of 3.0468 meter from the free surface of liquid, and as we have discussed that the center of pressure is always below the center of gravity of the immersed surface. So this is h star. So here as you can see, h bar is 3 meter while h star is 3.0468 meter, which is greater than 3 meter. So hence it is also observed that the center of pressure will always lie below the center of gravity of the immersed surface. Okay, thank you.